All right, so 8-5 was your trapezoids and your kites, right? So the trapezoids, obviously, definition of a trapezoid is exactly one pair parallel. So remember, these do not overlap with anything we've learned so far because everything we've learned so far is a parallelogram, right? We went, well, once we got more specific than a quadrilateral. So these can't be also a square, also a rectangle, or also a parallelogram, right? They cannot overlap. Does that make sense? So some of the properties are the same, especially in the isosceles trapezoids, but the actual shape itself cannot be classified as the other type. Yes? Does that make sense?
Yeah.
Yeah? Okay. Okay, so a trapezoid by definition has exactly one pair of parallel sides. If it's an isosceles trapezoid, then it has congruent legs, right? The bases are those parallel sides, which in this case, this would be a base, this would be a base. These are called legs. And if the legs are congruent, then it's an isosceles trapezoid. And if it's isosceles, then the base angles are congruent, right? And also diagonals are congruent. So we know two things about the isosceles trapezoid. So if you're looking at this first diagram, we just said if it's an isosceles trapezoid, which it is, the base angles are congruent. So this would equal this. That's 56 there. And then these are still parallel lines with same side interior, which means that these would still be supplementary. So if I did 180 minus 56, I get 124, and that's going to be either of the other angles. So A is 124, C is 56, and D is 124. Number 2 says that the lengths of the mid-segments of the trapezoid are given, right? And you want to find, or sorry, the length of the bases are given, and you want to find the mid-segment. When you have a mid-segment to a trapezoid, which is going to connect the two midpoints, I would find the length by doing what?
1/2 times 17 plus 32.
Good. So 1/2 base 1 plus base 2, or base 1 plus base 2 divided by 2, same thing, right? So 17 plus 33 divided by 2, and that's 50 divided by 2, which is 25. Number 3 and 4 are now dealing with kites. So a kite has consecutive sides congruent, right? So in this way, the way that it's turned, these two are congruent and these two are congruent, which actually pairs two right triangles that are congruent on either side. These two triangles would be congruent because of the right angle where they meet. These diagonals are perpendicular. And then they have a side shared side, which means hypotenuse leg, right? So those two would be congruent. And then also these two would be congruent, okay? It also tells you that the opposite angles are the angles where the one side of each pair of the congruency parts would be congruent. So this is congruent to this, not necessarily Y to W. So if I gave you that X, Y, Z, which is this whole angle here is 80, if those two are small congruent angles, that means that this is 40 and this is 40 if I needed to know them separately. And then X, W, Z, which is this one is 48, that would also mean that this is 24 and this is 24. So I also know that. Now there's a couple different ways to find those missing angles. One is I've got 4 right triangles. So I could add up the angles I do know and then subtract it from 180 if I'm given the 90 and the 24, subtract it from 180, I get that angle, okay? Or I know because it's a quadrilateral, all 4 angles are gonna add up to what? 360 degrees. So if all of them are 360 and I have 48 here and 80, I would subtract 128 from there. And I get 232, divide that by 2. And I get 116. So that means this top angle is 116, this bottom angle is 116. Now those are not necessarily bisected, so you can't just cut those in half. So if it asks for Y, Z, W, it's asking for this big angle on the bottom, which is 116. You could have also gotten there by doing the 2 right triangles and then adding them together. So you could do it a couple different ways. Yep.
So how come, because I added up all the angles and I subtracted by the mean,
In each triangle?
on only one.
So you'd have to do it in this. There are 2 different triangles there that form that. You'd have to do this triangle and this triangle. So this would be 50, right? Because it'd be 90 minus 40. And then this one would be 66. And you still get that same answer. So remember that those two are different triangles. The ones like above and below each other in this one are the same, but the ones where like where the non-congruent sides meet, those are going to be two different ones. Okay, and then number 4 said if XO, so I've got X, actually it says it's a kite, right? So XO Z.
Use the diagram there.
That's what I do.
Oh, the O is there in the middle. Sorry, I didn't think the O was there. I'm just going to redraw it so that it's neat. Okay, it says XO, which is here, is 2. OZ is 2, which makes sense. Those are congruent triangles. YO is 6. And OW is 8. Find the lengths of the sides of the kite. So remember that these diagonals have what in where they meet?
Right.
Right angles. These are 4 right triangles. So if I wanted to find this side here, it's the same as this. And if I want to find this side here, it's the same as this. So this is congruent to this to this. So I can do the Pythagorean theorem twice. I can do this triangle here. 2 squared plus 6 squared would equal that missing side, so let's just zy squared. 4 plus 36 is 40. And then zy would equal the square root of 40. Whoa.
2 square root of 2.
Good. It'd be 4 and 10, and that 4 comes out as a 2 root 10. That would be zy and xy. And then to find the other two sides, I'm going to do 2 squared plus 8 squared equals wz squared. This is 4 plus 64, 68.
So 2 square root of 6.
Good. That's, let's just say 2 and 34, 2 and 17, 2 square root 17. And that's wz and wx. Questions so far? Okay, so now we're talking about a kite. These, remember that they have consecutive pairs that are congruent. Where one congruent mark meets the other, those are the angles that are congruent. So this is congruent to this because I could divide those into 2 congruent triangles. So if I did this, that top triangle is congruent to the bottom triangle, right? It would be side, side, side. You cannot do that this way, though. Those are 2 definitely different shaped triangles. So top to bottom in this case are the ones that are congruent. If I did 100 plus 40, I get 140. All of them have to add up to 360. That's 220, and then divide it by 2, and that's 110. So each of these would be 110. Similar process on 19. These 2 would be the ones that are congruent, so this would be 110. And then if I did 360 minus all that's there is 220, 280. And what's left is 80 degrees for this one. So the angles that are congruent to each other in a kite are the ones where 1 tick mark meets 2 tick marks, not where the same tick marks meet each other, not where the consecutive sides meet each other. Questions so far? Okay, this is the chart that's in 8-6. This kind of 8-6 kind of like puts everything together, right? And the tricky part of your test is knowing these shapes so well that you're going beyond just like, here's a property, apply it. It's, you remember the always, sometimes, never kind of this is that. That's where you kind of got to figure out, you have to know the properties so well, you got to figure out what can overlap and what can't. So these properties, okay, on the left-hand side, can apply to some or all of what's on the right-hand side. And now that they're all together in one area, you've got to know what's what. So number 3 says all sides are congruent. In a parallelogram, rectangle, rhombus, square, and kite, which of those have all sides congruent?
Rhombus and square.
A rhombus and a square. So only those 2, rhombus and square. Okay, then comes both pairs of opposite sides are congruent. So what shapes have both pairs opposite sides congruent?
Rectangle.
A rectangle, a rhombus, a square,
Not trapezoid.
Not a trapezoid.
And not a kite.
Not a kite.
That's it.
That's it. No.
And a parallelogram.
And a parallelogram.
I didn't even see it.
Oh, yeah. That's easy.
Right. All right, next one says both pairs of opposite sides are parallel.
Rectangle, rhombus.
Rectangle, rhombus, square, parallelogram. Same set of four. If it's a property of a parallelogram, it is a property of all the other ones, right? Not all the other ones, but rectangle, rhombus, square. Yes?
Yeah.
All right. How about exactly one pair of opposite sides are parallel?
Trapezoid.
Just the trapezoid.
If it's a trapezoid, it can't be a parallelogram.
If it's a trapezoid, it can't be a parallelogram. There is one property that trapezoids, isosceles trapezoids have that other ones have, but it cannot by definition be a parallelogram. They have a property in common, but that's it. All right. All angles are congruent. Square, a rectangle.
You put rhombus.
I did. Square, rectangle. Thank you. All right. The next one. Exactly one pair of opposite angles are congruent.
Kite.
Trapezoid.
Kite.
A kite. One pair opposite angles is a kite. It's okay. We don't have to yell at each other. This is all in good fun. Yeah. Diagonals are perpendicular.
Rhombus.
A kite and a rhombus. Good. And because it's a rhombus,
It's a parallel. I don't know.
Parallelogram.
it's a square.
It's a triangle.
Oh.
Oh, because
All the properties of a rhombus apply to a square, right? Remember if the rhombus and the rectangle had a baby. So if you highlight rectangle, you have to highlight square. If you highlight rhombus, you have to highlight square on this. Okay? All right. Diagonals are congruent.
Parallelogram,
Square,
rectangle, rhombus.
Rhombus, square, and kite.
And
Not
rectangle.
kite.
Not a rhombus.
Square and kite.
A square.
Not a kite.
Not a kite.
I know. Parallelogram.
A rectangle. Think about a kite. Yes, right. The longer that side is, the more mismatched they're going to be, right?
What about parallelogram?
A parallelogram, they bisect each other, but same thing. The longer that pair of sides is, the more the difference between those lengths would be, right? It could slant all the way.
They're not all congruent.
No. All right, last one says diagonals bisect each other, and this happens.
For all of them except trapezoid.
All of them except trapezoid and kite, because it only has one pair of the diagonals bisects. So the parallelogram, the rectangle, the rhombus, the square, okay, they all bisect each other. Yes.
What chapter are we in?
8.
Okay, this is a. Wait, no.
That's diagonals are congruent in an isosceles trapezoid. It's still not, but that's any isosceles,
Oh, okay.
right? I mean that's any trapezoid. So if it had added on isosceles trapezoid, that's really hard to read. If they had added on isosceles trapezoid, then the diagonals would have been congruent. Does that make sense?
Yes.
Okay. Mhm. So a lot of the questions on your test are going to pertain to this. Like which of the following statements is true? Which of the following statements is false? And you have to know the properties so well that you can look through them and say which one's true and which one's not. You also have to be able to overlap them, right? Like a square is always a rhombus, true or false? A square is always a rhombus.
No.
A square is always a rhombus? True. By definition, a square is a rhombus and a rectangle combined, right? So a square is always a rhombus. Is a rhombus always a square? No. Does that make sense? Yes. So if they can be, it's a sometimes, right? A rhombus is sometimes a square. True statement, right? A trapezoid can never be any of the other ones. Because a trapezoid has exactly one pair parallel, right?
Not everything is.
It can't be a kite because a kite can't have only one pair parallel.
Can a kite be anything else?
A kite, well, a rhombus is a kite, but a kite is not necessarily a rhombus. It's a sometimes.
A kite is a rhombus always?
A rhombus is a kite.
When is a rhombus a kite?
Because a kite, by definition, has consecutive sides congruent. A rhombus has consecutive sides congruent. It just also has
because
all
rhombus
sides.
is
So a
always-
square can also be a
I
kite.
thought a kite was consecutive.
Right.
And a rhombus is consecutive.
All. A rhombus is all.
And the
So then
kites, the
how is
sides
a
are never
rhombus
parallel.
sometimes-
So if this is true,
Oh, we're gonna get a lot of like
That is a rhombus. That's by definition that has consecutive, right? That are congruent. But guess what? Are the consecutive sides congruent on that? A kite is not a no, they're not the same thing. Careful. A rhombus by definition is a kite, but a kite by definition is not a rhombus.
What is going to be a rhombus? What is
Square, yes. So ready?
No.
Look at the first shape. It's horribly drawn.
Square.
But all four sides are congruent, yes?
Yes.
That is a rhombus. Yes?
Yes.
Yes.
Do consecutive sides are consecutive sides congruent in that?
Yeah.
So it is so it is also a kite.
But I thought kite was only consecutive, not.
Yeah, but square.
But
also
what does
has
consecutive mean? One after the other, after the other, after the other, yes? So a kite only needs
One pair.
two, they need two separate, right?
Okay.
They don't have to have all four the same.
Yeah.
Oh, so it's like a rectangle.
What? Now we're
No, a rectangle is not consecutive at all. A rectangle is opposite.
Oh.
Opposite side.
So if I draw for you a square, if I draw for you a square,
What's square?
are consecutive sides congruent?
Yes.
So this is also a kite.
But a kite is not.
If this is a square, this is a rhombus, this is a kite, and a rectangle,
And the rectangle.
and a parallelogram, and a quadrilateral. That is everything but a trapezoid.
Everything but a trapezoid.
And
So I only use like 5.
Because-
It's also a kite because by definition, a kite just has to have consecutive sides congruent. This does. These two are congruent, and these two are congruent, and these two are congruent, and these two are congruent. Yeah.
So by definition, a trapezoid only has exactly one parallel opposite side.
Correct.
And then by definition.
If it had two, then it would make it a parallelogram, and it can't.
Isn't trapezoid technically?
Those are both trapezoids. Yes, they both have exactly one pair of parallel sides.
Oh, I
The top one is just a regular trapezoid. The bottom one is an isosceles trapezoid.
Oh, the parallel?
That's the only thing
Oh, 'cause
that
it's
is.
congruent.
So once it's isosceles, then I know that these are congruent and these are congruent, and I know that diagonals are congruent. And in a regular trapezoid, I only know that these two are supplementary, these two are supplementary, and all four add up to 360.
Because that would be
That's a quadrilateral.
interior angles.
Yes.
And that one,
Same consecutive interior.
those are the same, but it's also base angles there, right?
Yes.
No, she's
But if a non-isosceles triangle, trapezoid, one of them has to be congruent. One of the base angles one pair of base angles has to be congruent, right?
No.
But if one of them is, then that means it's a trapezoid. Isn't that one of
If these are congruent, then it's an isosceles trapezoid.
It's fine.
Okay, if one of them is congruent.
Yeah,
that
because
would-
then they would be supplementary,
if
so they would
one of
also be.
them- If one of the base angles are congruent, then that would prove it's an isosceles trapezoid.
Yes.
Okay.
Yeah. All right, we did a lot of talking about the quadrilaterals. Let's go way back to A1. Okay, these notes again are on Canvas on the module. So the first thing we're talking about is 8.1 was the angles in a polygon. Remember that there's a bunch of different formulas you got to remember here. You got to carefully pay attention to specific words, right? Like the sum of the interior. Keywords there being sum and interior is n minus 2 times 180.
Hey, where is it?
This is on the module under where it says test and review. Okay, then we had sum of exterior, 360 no matter how many sides, right? Sum of the exterior.
Can't find it.
Dude.
all the way down.
Just read the. Oh my god.
Okay, then for just regular polygons, so only for regular polygons, we had each interior.
N minus 2 from 180 over.
Good. And we had, God bless you, each exterior.
360.
Good. We had to know things like a hexagon, a heptagon, a pentagon, a dodecagon, an octagon, a nonagon. What am I missing? All the shapes, right? Triangle and up. You need to know their names so that if you get to a question and it says how many angles are in the interior of a heptagon, you have to know that that's sides 7. And then there was a lot of application of all that stuff, right? Which is there's some on the review. Okay, then we went into 8.2 to 8.6. So I put 8.6 on there because we kind of just talked about it, but it just puts everything together. Okay? And this is like one big Venn diagram, right? There's some separation, but overall, there's some overlap as far as especially the 4 parallelogram, rhombuses, rectangles, and squares. The very outer box is a quadrilateral. So there's only a couple things we know about quadrilaterals, but what's one thing? It has 4 sides and all interior angles and exterior, right? Interior and exterior angles sum to 360. So that we know about every quadrilateral. Then we went more narrow and started talking about parallelograms, right? So parallelograms, by definition, have what?
4.
God bless you. Opposite sides are parallel. Then we learned 4 more sets of properties. What else about the opposite sides? Good. Then opposite angles are congruent. Diagonals bisect each other.
And then one pair of parallel sides.
That's to prove their parallelogram. There's one more. Nope, there's
The consecutive angles are something.
good. God bless you. Okay, then came the rhombus. A rhombus has 4 congruent sides. And we know 2 additional properties to a rhombus.
Opposites are parallel.
Yeah, well, that's all the stuff. We know everything about the parallelogram, right? But then we learned 2 more things that are specific to a rhombus.
The diagonals bisect each other, which then they're congruent.
Diagonals, not congruent, are perpendicular. And they do what to the angles? Bisect opposite angles. They are not congruent.
The diagonals aren't congruent.
In a rhombus, they are not congruent. Think about the slant, right? The further it's slanted, the more different they are.
Everything that applies to the parallel.
And then everything that applies to the parallelogram, yep. And then we're missing the properties of the rectangle, but the next thing we'll go to is rectangles. Definition of a rectangle is 4 right angles. So it is also a parallelogram, which means it has all the properties from above. And then we know one more thing about a rectangle.
Angles are congruent. Well,
The
no.
diagonals
All
are
right
congruent.
angles.
Diagonals are congruent. And then all that is true for a square. Okay, if a rectangle and a rhombus had a baby, it'd be a square. All the properties of all that stuff carry down into a square.
Rectangles would just.
Go trapezoid.
One pair.
Exactly 1 pair, right? Which means no more, no less. Opposite. And then isosceles has congruent legs, base angles that are congruent, and diagonals that are congruent. Yep.
So for the rectangle, how come the diagonals don't bisect opposite angles?
They don't bisect the opposite angles because the taller that side is, the bigger the gap's going to be on that angle. Does that make sense? Okay, kites are just consecutive sides.
Exactly 1 pair of rectangles there.
Consecutive sides, congruent, and diagonals perpendicular.
Bye, Miss Chris Weiser. Have a good
Bye,
day.
guys.